You know, the world can feel pretty chaotic, right? Just a random jumble of things happening. But what if I told you that underneath all that noise, a lot of the connections around us, from how you get paid to how long a road trip takes, actually follow a few really simple mathematical rules? Well, today we're going to pull back the curtain and uncover the secret math that shows how things are related.
Just think about it for a second. The more hours you work, the bigger your paycheck. The more you study for a test, the better your grade, usually. We kind of get these connections intuitively, and it turns out there's a really clear mathematical language that describes them perfectly.
And when you boil it all down, it really comes down to two main patterns. On one side, you've got things that move together, in lockstep. As one goes up, the other goes up. Think more sales, more commission. But then you've got the other side, the seesaw effect. As one thing goes up, the other comes down. Like when you drive faster, your travel time gets shorter.
All right, so let's start with that first pattern, the one where everything just moves together in perfect harmony. In the math world, this is called direct variation. To see this in action, let's meet Nicole. She's a car salesperson, and her pay structure is super straightforward. She gets a 16% commission on every single car she sells. This means her earnings are tied directly to her sales.
And just look at the pattern here. A $4,600 sale gets her $736, but if she doubles that sale to $9,200, bam, her earnings also double to $1,472. There's this perfect, predictable connection between the two.
And what you're seeing right there is a perfect example of what mathematicians call direct variation. It's basically any relationship where two things go up or down together at a constant rate. If one doubles, the other one doubles. If one gets cut in half, the other gets cut in half. It's as simple as that.
And the math behind this? It's actually really elegant and simple. We can describe this whole relationship with just one little formula, y equals k times x. In our example, y would be Nicole's earnings and x would be the sales price of the car. Now, the real key to this whole thing is that letter k. That's the constant of variation. You can think of it as the secret rule or the magic number that defines the entire relationship. For Nicole, that number is her 16% commission, which we write as 0.16. It's the gear that connects her sales directly to her paycheck.
Okay, so we've seen things that move together. But what about the complete opposite? Let's talk about that seesaw effect, where one thing goes up as the other comes down. This is what we call inverse variation.
I mean, what happens when one thing going up actually forces another thing to go down? This kind of relationship is just as common in our lives, but it follows a totally different rule.
Let's take another example. Picture a tourist who's planning a road trip. The total distance they have to drive is already set. The destination isn't getting any farther away. Let's say that total distance is fixed at exactly 100 miles. That number, 100, is our constant. It's the anchor for this whole relationship, and it's not going to change.
So, if our tourist drives at a steady 25 miles per hour, the trip takes 4 hours. But watch what happens if they double their speed to 50 miles per hour. The travel time gets cut in half, down to just 2 hours. One side goes up, the other goes down. It's a perfect seesaw.
And that right there is the core idea of inverse variation. The two things are totally linked, but they're always moving in opposite directions. One's gain is literally the other's loss.
The main principle is just so simple and elegant. As one quantity gets bigger, the other one has to get smaller. That's the fundamental rule of this whole seesaw effect.
The formula for this kind of relationship is also beautifully simple. Y equals k divided by x. See the difference? Instead of multiplying like we did before, now we're dividing. And that one little change, that division, is what creates the entire inverse seesaw relationship. Okay, but let's be real. Life isn't always a simple one-to-one thing. Sometimes an outcome depends on a bunch of different factors all working together. And that's when we get into what's called joint variation, which is kind of like a team effort. Think about how you'd calculate the cost of a school trip, for instance. The total price isn't based on just one thing, is it? It changes based on both the number of students who are going and the distance they have to travel. You've got multiple factors all working together to get to that final number. And that's joint variation in a nutshell. It's just what happens when a result depends on two, or even more, other variables. You can almost think of it as a mashup of the other patterns we've already seen, just with more players in the game. So we've got these three types of variation: direct, inverse, and joint. But so what? Why does any of this actually matter outside of a math class? Well, because these ideas give us an incredibly powerful way to understand the world around us.
So let's just do a quick recap. We've got direct variation, which is that moving together effect with the formula y equals kx. Then there's inverse variation, which is the seesaw, described by y equals k over x. And finally, joint variation, the team effort, where multiple variables get in on the action.
So here's the real takeaway from all of this. This isn't just some abstract math. It's a language that lets us describe the world. It lets us find that one secret rule in a complicated situation, build a model, and then, and this is the most powerful part, make predictions. It's all about uncovering the hidden logic that connects everything around us.
So I'll leave you with a question to chew on. Whether it's in your work, your finances, your health, or even your hobbies, what predictable patterns are defining your world?